Okay, so additional topic number 3 is partial fractions. So we're going to try these 3 examples. It says add the following fractions in order to get one fraction. So you're going to have to get a common denominator. Okay, so if I'm going to get common denominators, this first one I'm going to multiply by x plus 2 over x plus 2. The second one I'm going to multiply by x plus 1 over x plus 1. So I get 3 times x plus 2 plus 1 times x plus 1. And it's all over the same denominator, which is now x squared plus 3x plus 2. So I just FOILed. So it's 3x plus 6 plus 1x plus 1 all over x squared plus 3x plus 2. So I get 4x plus 7 all over x squared plus 3x plus 2. Yeah, right there, George. You need to get water? Go get water. All right, now on the next one, what do you need?
Jolly Rancher?
It's the Jolly Rancher.
Never had anybody choke on a Jolly Rancher. Oh, man. All right, so I have x minus 1. So I need x minus 1 on the top and bottom, right? So I'm going to get 5 times x minus 1.
Brian, if he's not back.
What? I know you're talking about.
Yeah, I was going to say, Brian, if he's not back in about a minute, then go check on him. We didn't actually want you to be collapsed and dying in the bathroom.
Speak for yourself.
Okay, fine. Molly didn't want him to drop dead while we're just doing partial fraction. Maybe Brian did.
All right, here we go. So do you see
Okay,
why I
you just
didn't multiply
take
this whole
plus.
thing by x squared minus 1? Because I didn't need all of that. Just like with fractions, if I had 4 and I had 8, I don't need to make them both 32, right?
Yeah.
You just multiply the first one by 2 over 2. All right, so when I do this, I get 5x minus 5 all over x squared minus 1 minus 2 over x squared, so plus a negative 2 times x squared minus 1. So I get 5x minus 7 all over x squared minus 1.
We need a test on this.
It's going to be on the test.
So, is this going to...
You guys did this in pre-calc, right? Okay, next one. So I need this to be x squared minus 4 over x squared minus 4. And the other one needs to be x over x. So when I do that, I get x squared minus 4. I'm going to do a lot of this in one step. Plus x all over x times x squared minus 4. So x cubed minus 4x. I don't think so.
Oh, never mind. I skipped a step.
All right, so I get x squared plus x minus 4 all over x cubed minus 4x. That's it. Okay, so these were our basic forms for partial fractions. So we're going to do the opposite. So see if we start with something like this 4x plus 7. See how it's the product of 2 linear factors, x plus 1, x plus 2. Okay, so if this can factor, it can break into a number over a linear factor plus a number over a linear factor. Okay, this next one, see how we had x squared minus 1. So I broke it into, it could be x plus 1 and x squared plus, or minus 1. Okay, and then this last one, I had x and I have x squared minus 4. That one breaks into x plus 2 times x minus 2. Okay, so we're going to go backwards. Okay. So sometimes in calculus we have to break large fractions into the sum of simpler fractions. That's just going to allow us to integrate and things like that easier. So it says these simpler fractions are called partial fractions. It says the sum of the partial fractions is called the partial fraction decomposition. Okay, so I'm just going to do examples for these 4 possible cases. So if I start with something let's say it looked like x squared minus 5x minus 6 on the bottom.
Example.
Okay, I don't know what's on the top. Okay, it's going to break into its factors on the bottom. X minus 3, or no, not x minus 3. I factored it wrong, didn't I? This is x minus 6 times x plus 1. I'm writing, but it's not writing. X minus 6 times x plus 1.
Woo.
Okay, so I'm going to have x minus 6, and I'm going to have x plus 1. What we're going to have on the numerators are 1 degree less than what was on the denominator. So if I had degree 1, x to the first, it's just going to be a number, right? So we're going to call it a and b. Those are just numbers.
Could you give us an example?
Yeah, we're going to do lots of these. All right. So let's say we have a product of linear factors, some of which are repeated. So let's say all of this factors as x squared times x minus 4 cubed. This could be hard, but. Okay, here's how you'd separate. You'd have the first one, and then I repeat until I get to the most that it has. So x squared plus the next one would be x minus 4, but then I have to keep multiplying by itself till I get to the most that I had. Okay, now I told you the numerator is going to be 1 degree less, but when it comes to these repeated factors, you're just talking about what's in parentheses. So it's 1 degree less than what was in parentheses for the repeated. So if I have x on top, I could have a number, just a. X squared, that's repeated. It was x times x, so it's just b. Did you guys do this in pre-calc? I feel like Mr. Napier teaches this. I watched him teach it this year. So C, D, and E. So even though this last one is x cubed, if you actually FOILed it out, it was a repeated factor. So it's just 1. Since it was x minus 4, it's just E.
You're going to explain what A, B, and C are.
Mm-hmm. We're going to find them. Okay, let's say we have a denominator with irreducible quadratic factors. So what does that mean, irreducible quadratic? So quadratic means x squared, yeah. And so like x squared plus 4, you can't factor that. Makes sense? So it has imaginary answers like I was just saying. So let's say we have x squared plus 4, and then I have times x squared plus 1. Both of those are irreducible. So we don't know what's on the top. Okay, so that means it breaks up into the x squared plus 4 and the x squared plus 1. But on the top, I'm going to have 1 degree less. So if this was x squared on the bottom, it's going to be x on the top. So you're going to have a times x plus some number, b. Okay, this one's going to be c times x plus some number, d.
Why?
This is the setups. 4 possibilities. Okay, denominator has a repeated irreducible quadratic factor. So if I had x squared plus 1 squared, what do you guys think you would do for that one? What was that? Yeah, twice. So you have x squared plus 1 once, and then you have x squared plus 1 squared. And on top, I'd have ax plus b, 1 degree less. And then even though if you FOIL this out, it'd be x to the 4th, it's a repeated, so just use what's inside the parentheses. So it's like cx plus d. Okay, so let's put this all together and do some examples. So those are the 4 possible cases. Okay, so we're actually going to find the partial fraction decomposition of this function. So if I have 1 over x minus 1 times x plus 2, I know that it's going to break up into x minus 1 with a number on top, x plus 2 with another number on top. Okay, so how did you guys combine these fractions before? What did we do? Yeah, we multiplied this one by x plus 2 over itself. And we multiplied this one by x minus 1 over itself, right? So that means my numerator, I'm just going to talk about that. My numerator is going to be ax plus 2a plus bx minus b. And it's all over this denominator, the x squared, or x minus 1 times x plus 2. Does it make sense? You don't have to do the denominator. But what do we need our numerator to equal? 1. Do you guys see it? We need it to equal 1. So it's going to equal 1. Okay, so look at your like terms. I have ax plus bx. But how many x's did I have on my original numerator? 0. So that means that we have two equations. We have a plus b equals 0, because these x terms, we didn't have any x terms. Okay, and then these numbers, 2a minus b, what do they have to equal?
1.
Equals 1, right? The number, 1. Okay, what do you have? Yeah. See, this is a system of two equations. So add straight down. So when I add straight down, I get 3a equals 1. So a is 1/3. A plus b equals 0, so that means b is negative 1/3. So you can write this, I should have given you guys more room. You can write this as 1/3 over x minus 1 plus negative 1/3 over x plus 2. But we don't usually write fractions within fractions. Do you guys see what I'm saying? This original a over x minus 1 plus b over x plus 2. So I would write it as 1 over 3 times x minus 1. So 1/3 divided by x minus 1 is times the reciprocal, minus 1 over 3 times x plus 2. That's your answer. So that's how you break up that original fraction into two separate fractions. Then you'd be able to integrate, right? You could pull out the 1/3, pull out the 1/3, use substitution. But on this one, I don't know how to integrate that. See how it works? Okay, so let's do this one. So how would I break it up? Oh, I said do not find the numerical value of the coefficients. I was wondering why I only gave that much space. So we're doing part 2, basically. Do you guys see? Do not determine the numerical value of the coefficients. Yeah. Because a plus b equals 0. Yep. So if a was 1/3, b has to be its opposite, negative 1/3. Katie's being mean over there. All right, here we go. So how would I set this one up? So I'd have x on the bottom. I'd have x squared on the bottom. I'd have x squared plus 4 on the bottom. And I'd have x squared plus 4 squared on the bottom. So what numbers go on top? Well, what letters, I guess? A, I heard Steve say.
Steve.
I said it all.
B. What about this one? Cx plus d. And ex plus f, right? The repeated ones, just think about what's in parentheses, like that's x squared. Okay, we won't have to do that. You won't have to find all of those. So you'll usually have to find A, B, and maybe C. Okay, so we already did one like number 2. So let's do another one.